Welcome everyone. This is the first video on unclear, and today we will be doing a video and lesson on how we can graphically approach limits. So first, to begin with, we must know what is a limit. So a limit is the y value of a function as that function approaches a certain x value. And limits are typically written in this notation, which is that the limit of f of x as x approaches a, and a corresponds to any x value like 2 or -3 or whatever, and this equal sign, and this answer right here, which I'll label as L, capital L, is the y value that corresponds to it. Now, when regarding limits, there's a couple of certain things that we have to know. One thing is that for a limit to truly exist, it means that it has to exist from the left and right side, and those values need to be the exact same. Now, when you approach a limit from the left side, it's the same exact notation, just the one difference is that we have as x approaches a, and we have a negative sign on top. And this sign right here on top corresponds that it's approaching from the left side of it. Now similarly, if we were doing it from the right side, as you can guess, it will be the same exact notation, limit of f of x as x approaches a. However, a will have a plus over it, and this plus corresponds to the right side. Now if these two are not equal, let's say a is 2 for instance. So on some graph, as x approaches 2 from the left side, the y value is 1. However, as it approaches 2 from the right side, the y value is 5. When this happens, when the two values are not equal to each other, this means that the limit as x approaches, limit of f of x as x approaches 2, and then when we write the overall conclusion, we don't do any negative or positive signs which indicates left or right, because this means that the whole thing which intakes both the left and right hand limit, that means that the overall general limit does not exist, since these two values are not equal to one another. If they were equal, then simply if we just write down the same value up here over here. So let's say if this limit on the right hand side actually was indeed 1, then the limit of f of x as x approaches 2 would be 1. Now, so let's start with some examples. First, we'll start with something really easy. Let's have this graph, y equals x. Now this is just a straight line. So let me draw our quick Cartesian plane. Oh, that was really bad. Let's try and get it more straight. There we go. So let's say this is 1, 2, 3, 1, 2, 3. Same thing on the negative side. And then our line will go like this. Something like that, but of course more straight and accurate. Now in this case, let's say I want to take the limit of f of x as x approaches 3. And I'm also going to change this to f of x so you guys won't get confused, but they mean the same thing. Okay, so we know that the y values are 1, 2, and 3 here. Now, in this case, these arrows indicate that this line is increasing and extending forever. So if we do take the limit, if we're doing it from the right hand side, even though that it stops here, since the arrowhead indicates that it's extending forever, we can just simply extend it to help ourselves to graphically view this question. So again, if we want to take the limit, we need to take it from the left and right hand side. Let's start off from the right side. So limit of f of x as x approaches 3 from the right hand side. Now from the right hand side, this is how I would always do it, and this is really easy and straightforward. Honestly, just follow the graph until you meet your x value, which is 3. From the right side, as we go until we hit 3, we stop here. And what y value is this? 3. Therefore, the answer is 3. Now we'll do the same thing for the left hand side. Limit of f of x as x approaches 3 from the left. Again, just follow the graph going to 3 from the left side. We go until we hit 3 and we stop here as 3 is right here. And what's our y value? 3 again. Now that we know that both these values are the same from the left and right side, therefore the limit of f of x as x approaches 3 is 3. And that will be your final conclusion. Now, however, let's say I didn't have these arrows indicated. So I actually have 2 dots that indicate that this is the endpoint of the graph. Now this is a bit of it kind of gets tricky here, as students typically get confused and they make some minor mistakes. So if we're viewing this graph, if this is f of x, when we're taking the limit from the left hand side, again, we simply just follow the graph from the left until we reach 3, and we still get the same value, which is 3. However, the difference is that when we're taking from the right hand side, since this isn't extended, it stops here, there actually is there's no function here. There is no graph, as this is the endpoint. So anything beyond this doesn't exist. So there is no way to approach it from the right hand side, as there is no graph here to begin with. Therefore, the limit of f of x as x approaches 3 from the right hand side does not exist. Again, if you need more clarification, simply because this is the endpoint, again, it means that there is no function beyond this point, beyond this x value, which is 3. So since there is no function, we can't take the limit from the right hand side, as we have nothing to base our graph off of. So since these two are not equal to each other, if the function looked like this instead, the limit as f of x approaches 3 would be dne, as it does not exist. Now here's a quick little practice question that I set up. This function, you can see it's pretty weird. There's multiple holes, random filled in holes, and it just looks like a really weird question. And you might be asked to take the limit of a graph that looks somewhat like this. Now, although it may seem tricky, just follow the simple rules. Take it from the left side, the right side, and make sure that the endpoints don't confuse you. So let's start with this one. Limit of f of x as x approaches -2. -2 is right here. So again, we gotta take it from the left hand and right side. Let's start with the left side. Limit of f of x. That's really bad. Let me change that real quick. As x approaches -2 from the left. Now, so this is our endpoint actually right here, since this hole isn't actually a value, it's just a hole and it's undefined here. But here at -2, -3, this is your actual point and value. So with this being our endpoint, is there a graph that we can base the limit off from the left hand side? No, there is no graph. There's nothing that's approaching -2 from the left side. So since there's nothing there and it's an endpoint, from the left hand side, the limit does not exist. Now let's check from the right hand side. Now from the right hand side, again, if you just follow the graph. So let's start from here, we go, boom, and we stop here. Now, although this is a hole, the graph, it's still approaching the y value here, which is at 0. And this is one more important thing to take in, that limits, they can approach values that are holes. If there's a hole here, it doesn't mean that, oh, it's approaching -3, because this is the actual value. All it means is that it's actually approaching 0, since the graph on the right hand side, when approaching -2, stops here, which is at 0. The only case where you fully wouldn't even say like that it can't approach a value is when asymptotes, and we'll talk about that later on. So therefore, from the right hand side, it's approaching 0. Therefore, since these two are not equal, the limit of f of x as x approaches -2 does not exist. Now let's do one for f of x as x approaches 3. Again, we start off by taking the left and right hand limit. Limit of f of x as x approaches 3 from the left. Now, 3 is right here. Let's start from the left. We go, and then we go down, stop here. Again, this is similar to the last question. And even though the hole is here and the actual value is up here, that still does not matter, as the graph is approaching this hole. It's not going up like that, it's going down. So that therefore the f of x as x approaches 3 from the left hand side, the limit is approaching 0. Now let's take it from the right hand side. Limit of f of x as x approaches 3 from the right. Now from the right, again, we can just follow our graph from the right hand side and stop here at the same spot, which the y value is 0. Since these two are equal, therefore the limit of f of x as x approaches 3 is equal to 0. If you guys want more practice, you can pause right here and just take limits at values which we didn't cover today. For example, you can try and take the limit as we approach 4 or 2. One last example that I'll do today is 0, as this one is a newer example that we haven't covered yet. So let's make some room here. Alright, let's start. So we want to know the limit of f of x as x is approaching 0. Again, rule number 1, we split this into our left hand and right hand sided limits. So let's take the left hand side first. Limit of f of x as x approaches 0 from the left. Again, or simply we just follow. We go here, we left, we're approaching 0, and we stop here, and the y value is at 1. Therefore, when the x is approaching 0 from the left hand side, the limit is 1. Now let's do the same thing with the right hand side. Limit of f of x as x approaches 0 from the right. Now we go, and we just follow the graph and we stop here. And this y value is -1. Now, although these are very close, the numbers are very close to each other, in order for the limit to exist, they must be exactly the same. So therefore, since these are not equal, this function, the limit of the function as x approaches 0, still does not exist. Now let's try this example. Based on the graph below, answer the following questions. A. State all x values where the limit does not exist. And B. State the domain. Let's start with part A. Again, for a limit to not exist, this means that the left and right hand side are not equal to each other. A very good starting point is always do the endpoints. As endpoints, they're guaranteed to not have a limit. Let's start with -2, and we also have to prove it though, if you want to get full marks on your test. So the first points that come to my mind are -2 and 3. So let's check and clarify if the limit does not exist. Limit of f of x as x approaches, let's do -2, and let's approach from the left hand side. Again, from the left hand side, there is no graph that's approaching it, as it stops here. Since there is nothing that we can take the limit of from the left hand side, therefore when it's approaching -2 from the left, it does not exist. Now we take it from the right hand side. From the right hand side, as we can see, we approach -2, we keep on going, and we stop here. And the y value is at 3. However, since these two are not equal, therefore the limit of f of x as x approaches -2 does not exist. I'm going to save this for now, as at the end we'll write our total conclusion. Now let's do it for the next endpoint, which is at 3. Let's check here. The limit of f of x as x approaches 3 from the left. Now from the left, if you just follow the graph, we stop here, and the y value is 0. Let's make that better. Now let's try it from the right hand side. And again, I apologize for the bad handwriting. This is actually my first time writing on a mouse, and it's much different than a pencil. Alright, from the right hand side, there is no graph, and since there is no graph that we can approach it from, therefore it does not exist. So far, these are two x values where we have concluded that the limit does not exist. Now, let's check if there's more. So, one way to easily tell is if you see a big gap here, and we call it a jump. So you see here the value, it jumps from 0 all the way to 3. And it also jumps from here, which is around 1.5, to around, let's say, 2.8. So let's try and take the limit of both, and we see where this goes. Limit of f of x as x approaches 0. Let's take it from the left hand side first. From the left hand side, if you follow the graph, we approach 0 here, and here the y value is 3. Therefore, the limit is 3. X approaches 0 from the left hand side. Now let's do it again with the right hand side. And this notation is very crucial. You always have to write it, no matter how much limits you take, you always need to write it to get full marks. Alright, from the right hand side, let's follow the graph until we reach 0. Goes here, and we stop here. And the y value is 0. Now, since these two values are not equal, we can clarify that the overall limit does not exist here. Now, this last one to check, let's do when x approaches 2. limit of f of x as x approaches 2 from the left. Let's approach it from the left. We just follow our graph and we stop here, which is around 2.8, we'll say. Now let's take it from the right hand side. As x approaches 2 from the right, the limit equals, let's check. From the right, we go and follow the graph until we reach 2. And again, same y value, which is at 2.8. So therefore, this limit does indeed exist when x approaches 2. So we can erase this, as we don't have to worry about it. And that's our final answers. We have 3 points now. Let me quickly rewrite this one. Now, since these three limits, when they approach their x values, does not exist, our answers for A are that the x values where the limit does not exist are when x equals -2, 0, and 3. And you should also write the overall conclusion, which I can do for these two, but unfortunately since I'm running out of space, it'll be hard to fit this one in. But you always want to write the general statement so your teacher knows that you know how it works and that you can conclude that the overall limit does not exist. Does not exist. And the same thing here. The limit of f of x as x approaches 3 does not exist. So there's part A done. Now let's do part B. Alright. Part B states to state the domain. Now this seems like a pretty simple question, but most students get a bit confused and they find it trickier. So first, domain is simply where the x values where the function exists. Now here we have multiple jumps, holes, and this might confuse people, but let's stay focused. These filled in holes at the endpoints mean that the function does exist at those points. So we can start off by having our endpoints, which is -2 and 3. So our endpoints are when x equals -2 and 3. Now, we just follow the graph and we see problems or issues where the domain might not exist. Here we have a hole at 0, 3. Now, although there is a hole here, since at the exact same x value there is a filled in dot which indicates that the function exists, when the function is at 0, the f of 0 is 0, and this hole can be disregarded when talking about the domain. So f of 0 equals 0. Again, let's move, and boom, our next hole is here at 2. However, when we take f of 2, since again on the exact x value there's a filled in hole right here, this indicates that the actual value on the graph is 1.5. And then the function stops here. Now after going throughout the whole function, we know that since these holes can be disregarded, as right below them there are actual filled in dots which indicate that the values exist, this function exists at every single x value between -2 and 3. Now that we know that, we just simply write our concluding statement. So x is in the element of all real numbers, Let's make that better. Such that -2 is less than equal to, and this equal sign comes from the filled in dot, x, which is also less than equal to 3. There is our final domain, and that is part A and B both done. That'll be it for today's video. Hope you guys enjoyed, and if you have any questions, don't be scared to go on the comment sections, and we will do our best to answer you in the shortest amount of time we can. Thank you guys, and we'll see you next time.